record this just onto my computer just so we can send it to folks that weren't able to attend today. So just so you know that we are recording this. Like Kip said, thanks a lot for your time today. We really appreciate it. And I hope everybody's staying safe and sane as they aren't able to go through the normal daily routines. Let's see, we're scheduled for 30 minutes, so we'll endeavor to stay on track on that. Lots to cover, so let's go ahead and jump in real quick. Just a quick bio on me, so you know who's talking. I'm a regional manager for Penn Valley Pump, covering kind of half the US and Canada. My bachelor's of science and civil engineering from the University of Illinois, and you guys have two Big Ten schools. We got one here in Illinois as well. I guess we got two with Northwestern. 31 years experience on the water and wastewater equipment side of things. So worked as a rep at a large firm, kind of like the HESCO guys, as well as at a couple of different manufacturers. So proud to work with the Penn Valley guys. I was a rep for them for 13 years in Illinois. So been around these pumps for about 18 years and been around pumps and process equipment in general for 31. If we ever get out to start seeing people again, we can talk about more stuff, hobbies like hunting and shooting and have a beer and that sort of thing. But in the meantime, we will do webinars. Let me put this in presentation. Quick shout out to HESCO. Obviously, all you guys know HESCO since you've signed up through this through their email that got sent out, or LinkedIn, or some other things. But just want to say a quick thanks to Kip and Glenn and Kevin and the rest of the behind the scenes HESCO guys. They do a fantastic job for us. So if you need anything on the water and wastewater equipment side of things, basically you can take all the other reps line cards and throw them away and just call HESCO. That's the only guys you ever need to talk to. No, I know lots of other Michigan reps. So anyway, they do a really great job for us in We'll talk about pumps. We'll talk about positive displacement as well as centrifugal pumps. This may be the least salesy pitch you guys hear all year. We're really not going to talk about Penn Valley pumps at all. This is just a general sort of thing. It might be good for younger engineers or engineers who haven't worked on the pump side of things in a great detail. So that's kind of the gist of things. I guess a quick application note, we at Penn Valley obviously manufacture positive displacement type pumps, but you guys will use probably more so than that centrifugal pumps. If you can use a centrifugal pump, you should. They're way more efficient, cost less money, and in applications like out in lift stations, you're obviously going to use centrifugal type pumps, whether it's a dry pit or a submersible type arrangement. You would never see a positive displacement pump of any type out in a collection system typically, unless it was a really unusual situation. Positive displacement type pumps, which include our double disc pumps, as well as progressive cavity pumps, so Netch and Moino and CPEX and those guys, as well as old plunger style pumps or piston pumps, which we replace a lot of every year these days, or rotary lobe style pumps. Those are all positive displacement type pumps, which are used in applications which typically either pumping very thick slurries or sludge concentrations. You get up above about 3-ish%. It depends on the pump, and centrifugal pumps aren't going to be real happy. So that typically will force you into a positive displacement pump of some type. Or if you're metering to dewatering applications like rotary press or a screw press or a centrifuge or a belt filter press, that would be an application where you would use a positive displacement type pump. So as you have pump applications come up, obviously work with your local reps and their pump manufacturers to look at applications. But in general, if you can use a centrifugal pump, you should. And that means currently in my current job, I don't get to sell anything, but really you really got to apply it correctly from an engineering standpoint and use what would be best for the owner, for the plant guys. We'll talk about some design considerations here. Maybe just touch, if we have time, briefly on operation and then on troubleshooting. So again, this is intended to be an overview. Like I said earlier, this could be a couple semester course if you really wanted to talk exhaustively about pumps in general. So we'll just touch on some highlights and terminology, some experience that I've had over the years of dealing with troubleshooting and on the design side of things, where you see things that are done well as things that are not done well, and everyone learns lessons from that. The first bullet here, maintenance, operation, and staff. Every consultant that I talk to, and I think we had a number of consultants sign up here, probably more so than plant and operations folks. I always get on a soapbox and tell the engineers to make sure and involve not just the boss guy at the wastewater plant, but the maintenance guys and operations guys that actually do real work and work on equipment and make effluent and that sort of thing, because they will have fantastic ideas that guys like myself, as well as some folks on the consulting side of things that don't do regular maintenance on equipment every day, that might not think of. So make sure and involve that. You're going to have a design meeting, so you may as well have another guy or two in there that provides some really great advice. Every consultant I talk to and say that, they say, oh yeah, we always do that. But I can tell you, I'm in plants every week. Well, not this past month, but normally every week I'm in plants, and I get the comment that, man, I wish, why'd the engineer do it that way? So anyway, that's a little soapbox thing that I have. Piping design, again, just hitting some broad sort of topics on the design side of things. You want to not hang piping off of any equipment, pumps or blowers or any other kind of equipment. So here's a photo of a pretty beefy support on the discharge piping coming off of. Obviously, it doesn't have to be a giant concrete and a base elbow sort of thing like that. Stainless steel type support, but you want to support the piping independently from the equipment. In this particular picture, I'd rather have a floor mounted support here. Discharge piping, so you can see one over on the suction side of this pump. We typically like to see one on the discharge side. Probably the startup report on that said add a pipe support on the discharge side. Here's an example of maybe something not to do. This installation, back in the day, if you remember, if you're old like me, you'll remember that piping came out of a pump and then ran 2, 3, 4 feet off the floor. And it was kind of a pain in the butt for the operation and maintenance guys to have to step over, right? So with the advent of OSHA and everybody being kinder or gentler, we come out of a pump and we go straight up in the air, so we get it off the floor, right? Which is great from a day-to-day standpoint, but you have to support the piping well. This particular installation, you can see the pieces of all thread that were about 8 or 9 feet long, with no lateral support horizontally, no floor mounted support at all, and Victolic couplings, which contractors love and operators love them too, because they're quick together and quick apart if you need to take the piping apart. The problem is they don't transfer. They're not as stiff a joint as a flanged type joint. If you use on the consulting side of things, if you use mechanical joints or Victolic type joints, you want to make sure you use a rigid cut, and the Victolic guy will know what that means. Type of joint, so the two ends of the pipe butt up against each other, and it will transfer moment across that joint, more like a flange, not exactly, but it'll be a stiffer joint overall. But you have to provide support for piping. As Newton had a theory, as unless acted on by an outside force, things want to keep doing what they're doing. So when you take liquid and you come out of the pump and you turn a 90 and you turn a 90 and you turn a 90, it wants to keep going in the direction it was going. So that puts a force on it and can cause movement on piping. So pipe supports are a critical thing. They are more critical on a positive displacement type pump because there is a little bit of pulsing in all positive displacement pumps, and we'll talk about that more in a little bit. Centrifugal pumps, it's a little bit less critical, but again, you're changing direction of flow, and that puts, like you use a thrust block on a collection system, piping out in the collection system, you need to support that so things aren't going to move. Valves on the suction and discharge side of the pump. Obviously, we're going to do that. That's a thing that everybody does. But location, I've seen a number of times where the valve on the discharge side of the pump was 30 feet away from the pump, and it wasn't, in one particular case, it wasn't necessary. I don't know why it got put there. That's a whole lot of liquid in that piping that's got to get drained back out of the pump when they open it up to do maintenance on it. So put the isolation valves for when the guy's going to break open the pump and work on it. Put those in as close as physically possible to the pump itself. Suction piping, and we'll talk about MPSH and suction lift and all that sort of thing here in a little while, but all pumps, centrifugal as well as positive displacement type pumps will have short suction piping. And we'll talk about why here shortly. Check valves, when you've got multiple pumps going into a common discharge header, you're going to want to have a check valve. One pump has a higher pressure rating capability compared to another pump, so that's something that you'll use most of the time on pumps. I wrote 90-degree elbow on the pump inlet and outlet. That's fine to do on a positive displacement pump. We don't care. No positive displacement pumps care. You can come out and turn a 90 on centrifugal pumps. That's something to look at. Obviously, talk to your pump supplier, but they're going to want several pipe diameters worth of straight run of pipe coming into and going out of the pump just to have a nice uniform laminar flow coming into the pump itself. Gauges, I promise my only other soapbox issue. Put gauges on pumps, both sides of the pump, if it's a dry pit pump, on the suction and discharge side of things. The first thing a pump guy is going to ask when he gets his phone rings and there's an issue with the pump is, how fast is the pump running, RPM wise, and what are the gauge readings? That tells you where you're at on the curve. It tells you whether it's kind of a suction side problem or a discharge side problem or a pump problem. So it's a very good diagnostic tool. So many times, about a third of our business is replacing pumps where not part of a large project where just a guy has a pump that's giving him fits and he wants to replace it. And so the best way to understand the total dynamic head of that particular hydraulic system is to run that existing pump and look at the suction and discharge gauge readings. That'll give you the best estimate of total dynamic head for that particular system. So gauges cost tens or hundreds of dollars, and pumps cost tens of thousands of dollars. And so it's a cheap way of letting you know what's going on inside that piping system. Pressure vacuum switch assemblies. This is a positive displacement. When I say PD on that slide, that's a positive displacement type pump application sort of thing. You wouldn't ever do that on a discharge or on a centrifugal pump. What happens on a centrifugal pump if you turn it on and close the discharge valve? Nothing breaks. It goes to shut off head. Not pumping, obviously, since the valve is closed on the discharge side, but nothing breaks. You wouldn't want to leave it run there for a long period of time. But if you do that on a positive displacement pump, any positive displacement pump, this is the same for all types of positive displacement pumps, the pressure will, if you do that on the discharge side of the pump, the pressure will spike on you immediately, like really high, like 100 plus PSI. And something's going to break. On most pumps, it'll be the packing will be the weak spot. And so you're going to want to put a switch, and I'll show you a picture of that. This is what we use is you've got a snubber here or a sensor or an ISO ring that keeps the sludge out of the gauge, as well as the switch, the gray box is the switch. And that gets wired back to the starter or the VFD. You can run it through SCADA to sense the pressure. It has an adjustable thumb screw in there that you can adjust the set point of the switch to what pressure it trips at. But that protects the pump and keeps it from breaking. If it runs against a clog or a closed valve, it prevents things from breaking. So that's something you're going to always want to put on every positive displacement pump. You can put it on the suction side as well. It's not as critical there. Basically, what it is an alarm to tell you, Mr. Operator, you're not pumping. Because if the pump comes on and pulls a vacuum and trips that switch, that means there's almost a complete clog or a valve closed on the suction side of things. But definitely essential on the discharge side of any positive displacement type pump. Pulsation dampeners, again, that's a positive displacement type pump sort of terminology. This is what we use in our PD pump. You're going to see these on reciprocating positive displacement pumps. It's just a wide spot in the line for the sludge to bounce up and down on a cushion of air, as opposed to on incompressible liquid. And so it smooths out the flow and dampens out noise and vibration from a positive displacement type pumping system. We get the question all the time. I'll play this video here in just a sec about pulsing. Sometimes people think pulsing from a positive displacement pump means flow, no flow, flow, no flow. But you got to remember that pumps are spinning at 100 or 200 or 300 RPM. And when you design the pulsation dampening system correctly, here's what it looks like. I took this video when I was rep in Illinois. This is Creve Coeur, Illinois wastewater plant. Feeding a belt press, because you can see the sludge coming out of the flock tank. Here's the flock tank, into the gravity zone and going across the gravity zone before it goes into the belts to get squeezed for dewatering. So I'll play this video. So you can see the pump running. That pump happens to be pulling about a 16 or 17 foot suction lift and a very short discharge line. So there's not a lot of piping to attenuate any pulsing that might occur. And you can see it coming out of the flock zone where there's no visible pulsing at all. So it doesn't, you can use any kind of positive displacement pump to feed a dewatering type device. There's no process issues there. Check out time here. Suction piping. Again, all pumps love short suction piping. In some cases, you can't have a flooded suction where the liquid level on the tank you're pulling from is on the inlet to the pump. You can't do that. You have to pull what suction pump guys call a suction lift. In those kind of situations on the design side of things, you want to make sure you've got, I've seen an installation with knife gate valves, and some of those will hold against pressure, obviously, or material would leak out, but they wouldn't hold against vacuum. And I thought it was on a centrifugal pump. It was a Gorman-Rupp self primer, and it wouldn't pull the lift, and we fought it, and finally figured out that knife valve was not rated for vacuum. It was for pressure, but not vacuum. You had to switch those out in order to get that pump to pull the lift, because it's way easier to pull air in through some sort of leak in the suction piping than it is to pull liquid up, 5 or 10 feet. Liquid's very heavy, so that's one thing you want to check for on the suction lift type applications. Just a quick terminology thing. You'll hear pump guys talk about TDH, total dynamic head. All that is the sum of, the way I look at it, of the pressure work that the pump has to do. So you're adding your static heads. In this case, we're depicting, here's the tank we're pulling from. So the amount of pressure work that you have to do from a static standpoint is from this elevation up to the top here, up to this elevation, right? It's going to fall away here, but you have to get it up to this point. So your total static head, you subtract those two. So this is the amount of static work that the pump has to do. In a suction lift application, the amount of pressure work that the pump has to do has to get the liquid from this top of this blue level here all the way up to here, not just into the tank, but up to the high water level, since we're discharging below the water level in this particular drawing. So in that case, the total static head, you add those two together. On this flooded suctions example, this head from here to here, a positive static head on the suction side, is actually helping the pump, right? Helping it get up into there. That's why we subtract that off of the discharge side static to get the total static head. And then you're going to have friction losses, right? Where we calculate velocity and loss per 100 feet and elbows and equivalent lengths and that sort of thing. And you add that all up, and that gives you your total dynamic, not static plus your friction losses gives you your dynamic head. And that's what pump guys use to size. That's the amount of pressure. So we got to have flow and head, right? Flow and total dynamic head to size the pump. The friction loss calculation, we typically will run, whoever's doing that design, typically it's the consultant, on water, right? We have charts for water, and then you convert for a certain amount of 3% sludge or 4 or 5 or 6% sludge. You have a conversion factor, which will increase the cost that the system's going to see. One note on polymerized sludge: when polymer gets added to sludge and it gets pumped, it's one thing you want to be careful with on the design side of things, because it's differently than sludge without polymer in it. And I'll leave it at that since we're running short on time here. But that's something that you want to work with your pump guy and make sure to let him know that there's polymer in that sludge, because the friction losses can be significantly higher than if it doesn't have polymer. Another thing you might have on a belt filter press, and some screw press guys do this, is a mixing valve, where it kind of looks like a weighted check valve, where as the polymer is injected, that helps mix the sludge and the polymer together. And those things can have significant amounts of pressure drop across them. So you're going to want to add that into the system as well. Yeah, you don't want to miss that. Connect as much as the static head or more so. So that's. Or if you've got an existing pumping situation, as I said earlier, you can run the existing pump, look at the section readings, and that kind of lets you know exactly. You might have 8-inch piping and you have 400 gallons a minute, so the friction loss is so many feet per 100 feet of length of piping. But that might be struvited or corroded down to a 3-inch pipe, and so the friction loss is going to be significantly higher than you would calculate theoretically. So if you've got a gauge there, you can run it, and the gauge kind of lets you see inside the piping. And if it is corroded down to a much smaller diameter on the inside, that gauge will tell you that. So gauges are great, again, for sizing pumps if you've got an existing pump, as well as diagnostic testing things. MPSH, this is a giant topic. I'll mention it only briefly. Cavitation is what we're talking about here. So basically, if you have long suction lines or small diameter with high velocity and or high suction lift applications, where the pressure in the pump or in your suction piping can drop below the vapor pressure of the liquid you're pumping, and that forms little air bubbles inside. And then when that pressure rises back up again, those air bubbles collapse or implode, and they're like little mini explosions, and it can seriously tear up a pump. A couple of impellers from centrifugal type pumps, which experience cavitation. It will sound like gravel is going through the pump. It's not. It sounds like that. That's the little implodes of the bubbles after you come back up to from that very low pressure where you've gone below the vapor pressure of the liquid. Then they implode and they do terrible damage. Those are pumps. I couldn't find one of our pump. I'm sure you can cavitate our pump as well. There's no magic there. This is a hose from you can see some effects, early effects of cavitation. So again, that's not the pump's fault. That's the guy that put it there. You didn't ask the right questions on the design side of things. We'll skip over the operations side of things. Troubleshooting. Make sure your guys at the plant, and this is for Todd and some of the guys at the plant, make sure they have the tools to whatever kind of rotating equipment they have. Obviously, you're going to have an amp meter. Infrared thermometers are great for taking bearing temperatures and monitoring those and trying to catch a bearing before you run into a problem and replace it before it locks up and breaks a shaft or that sort of thing. A tachometer is something that almost nobody has, and they cost about $20 on eBay. You can get a fancy one for a couple $100, but knowing the speed of a piece of equipment is another great way to troubleshoot things if things aren't going right. Again, pressure vacuum gauges. A vibration meter is a centrifugal type pump sort of thing. You wouldn't ever use one on a positive displacement pump. It would send it off the chart. But that's to check centrifugal type loads. So those are some great tools that the guys at the plant can have to help diagnose issues. And then finally, on the troubleshooting side of things, everybody hates it. I can tell you, when the guy with the shirt that says, the name of the company, and that matches the name of the piece of equipment that's sitting there. And what are some examples? There are some symptoms, nothing coming out the discharge pipe onto the belt press, or the pumping rate is way down, or there's noise, or there's vibration, or the parts are wearing out quickly. That's the kind of thing that can cause a pump guy's phone to ring with a guy on the other end who's a little bit on the upset side of things. So when that happens, I learned about pumps from a cantankerous old bastard a long time ago that I thought he was full of it, but we'd be at a site and there'd be a problem and he'd say, it's not the pump. And I'm like, it's gotta be the pump. That's the thing that's going round and round, and there's nothing coming out the discharge. But I can tell you, after 31 years of doing this, and you hated to give that guy any credit because he was, like I said, he was kind of a grumpy old sod. But he was right. My guess is 80% of the time, it's a hydraulic issue. The vast majority of the time. Sometimes it's a pump issue. We run into that from time to time. But some of the things on the pump side of things, what could it be? I mean, you could certainly have an impeller that's worn, or some tolerances between a wear plate and impeller that need adjusted. You could have the rubber parts on a positive displacement type pump that are worn out. And that's on any kind of positive displacement pump. And the plunger on the can that goes up and down on an old piston pump could be hourglassed, and you get slippage backwards, or the check valves aren't seating. You could have I've seen this, a broken shaft. So the motor's spinning, but either the shaft of the pump is broken, or the thing has come undone, or the V-belts have come undone, and the pump itself is actually not spinning, even though the motor is spinning. Sounds really silly, like somebody should catch that, but I've been called out to sites where that was the case. You go, gotta fix that. On the hydraulic, so it can be the pump. It certainly can be, but on the hydraulic side of things, you could have an MPSH issue. And again, that's not the pump's fault. I've had applications where guys wanted to replace pumps, and you start asking questions, and you got a 600-foot long suction line, and the guy wants 300 gallons a minute through a 6-inch pipe. You know you're starving the pump. That pump that's there that he hates, that he has to work on every 3 months and spend thousands of dollars on, it's not that pump's fault. It's the guy that put it there. It's his fault. It's an application engineering issue. I told that guy, I happened to be out in Kansas, and this dude was ready to buy a couple of pumps. And I said, I feed my kids selling pumps. I love to sell pumps, but you would hate my pump too. It would do the same thing. So I said, you either need to move the pump closer to the tank you're pulling from, or get a way bigger diameter suction pipe, or a great big giant pump turning really slow. Those are the ways you solve those in retrospect. But in that case, it was an MPSH. He was starving the suction and cavitating that particular pump. Pumps can get airbound. I've had the start of the suction piping become exposed out into the air, right? The liquid level is below the start of the suction piping. I know that sounds insanely silly, but that has been numerous times the cause of pumping in my phone ringing. Typical ones are running it against a closed valve or a clog. That's a very common application, but another one was if the TDH is too high. We all do calculations, and I've had applications on PD pumps. It doesn't matter, right? We all are a little bit conservative, because generally speaking, the flow is going to be the same if a positive displacement pump spins at a certain RPM. It's going to do a certain amount of flow when it's pushing against a certain amount of total dynamic head. And if that head changes by a few feet or even more, it's going to make a difference. On a centrifugal pump, you can fall off either side of the curve pretty easy if you've overestimated or underestimated the total dynamic head. And I've had that happen before as well. So that's something that is a big deal, more of an issue that you see on centrifugal type pumps. And the other thing is you get controls issues. We're coming up on time here, so I'll wrap it up real quick. Level sensors not turning pumps off or not turning pumps on. Pressure switches, again, turning pumps off prematurely. VFD, I've had issues where the VFD was not programmed correctly and it was tripping out on amps, or it was sending different hertz than we all thought it was supposed to be sending. So that's an issue that we run into occasionally. But it's typically going to be a hydraulic type issue that you run into when pump guy's phone is something's not correctly. Here's your very quick commercial salesy side of things. Get a hold of Kip or the guys at HESCO if you need positive displacement type sludge pumps. We may have a good solution for replacing an existing pump, or if you're working a big with some positive displacement pump. Dry. The plant guys love them. It just a lot of advantages if it's an application where we would fit well compared to some of the other options that are out. I think in conclusion, I think if there's one thing that you guys take away today, it's this: that pumps are simple creatures. They spin at a certain RPM, and there's a pump curve, and that pump curve will describe the flow rate and the head relationship. And that's it. There's nothing. Pumps are very simple creatures. And by the way, the pump is always on the curve. I've had people say that when there was a pump issue. Well, the pump's not on the curve. Well, by definition, the pump is always on the curve. The pump doesn't have a mind of its own where it decides on a given Tuesday that it's not going to be on the curve. It's always on the curve. That you have to look at the rest of the hydraulic system in order to look through as you're working through troubleshooting things. And that's the key point. The most important thing that you got to consider is the hydraulic system into which you pump. That's the crux of the biscuit, as Frank Zappa would have said. You got to knowing how to do that well is critical. So work with your pump partners, with your reps and your pump manufacturers as you go through the design, because they do that every day, right? You guys don't do that every day, and that's the value that the pump guys can add, is to help prevent problems down the road, because we all want to avoid the giant "oh crap" moment when you push the go button on any piece of equipment. So you can hopefully help ask those MPSH questions and application engineering questions to make sure we get a good application. If your pump guy that you're talking to isn't asking those kinds of questions, you might consider whether you're talking to the right partner on the design side of things, because pumps are not glamorous parts of a water or wastewater plant, but when they don't work, it's kind of a big deal. So yeah, make sure and work with your partners on the design side of things. So, and that's it. And we're 2 or 3 minutes over. Any questions at this point?
Yeah, Steve Kipp here. I don't see any questions coming up in the chat. If you want to ask a question offline, we can always Steve and I can take care of that. If you want to send an email, we can always do it as a separate little quick phone call. If you're strapped for time right now, I'll leave it open for a second here, see if any questions pop up. If not,
this is Sally. I don't know if you can hear me. I couldn't find the chat button. Sorry.
Go ahead, Sally.
I just had a question on the gauges. You know, even when we put suction and discharge gauges on piping with nice red valve isolators and all that stuff, a year later I go back out to the pump stations and they're on the floor because the guys complain they're too much to maintain. Do you have any thoughts on that?
Putting a red valve isolation ring, or we have effectively the same thing on our scroll back up on our assembly we put on the top of our dampeners.
Yeah, I saw that on there. Yep.
Yeah, those certainly help because they keep the sludge from outside the gauge. The inside of it is a piece of rubber of some sort that is flexible enough to allow the line pressure to push against that rubber sleeve, and it pushes against the glycerin in the outside of that sleeve, and it presses on the gauge or the switch. So that will certainly lengthen the life of a suction gauge or any kind of gauge or switch. It is a wear item, and if that breaks, the sludge will get in there, and in a matter of weeks, it's not going to be reading correctly. So it is a maintenance sort of thing that periodically has to get replaced. We haven't ever found anything better than the one we use. We have it made for us. But red valve makes a great isolation ring, which again, it's got a life. It's got a rubber in there, and it's got sludge going through it, and it will wear out from time to time. So I understand exactly what you're saying, and I've experienced the same sort of thing. A lot of times we'll say, do you have gauges? And they're like, yeah, but they don't work. You know, if we're trying to find out what the TDH is of an existing system. And
what do you think about putting a spot for a gauge in and then just sort of leaving them off and putting them in, you know, like a
yeah,
tap?
that's or isolating it, having a little quarter turn Nibco type valve to keep the sludge out of it.
Yeah.
Yeah, absolutely. Because most of the time, what we recommend is when they run by, guys run things on sound, and they can, and oh, that doesn't sound quite right, you know, if they walk by it sounding funny. And monitoring, you know, monitor the pressure, see what they normally run, what the gauges on both sides of the pump normally say, and then if it's way different than that, you can go, oh wow, it's normally not that high. So if the gauge is off, you do that. You can turn that valve and then isolate it back off. So yeah, that's a perfectly fine idea as well. Any other questions?
Sally, did that answer your questions for you there, young lady?
It sure did. And it's a good thing I don't have the video on. You wouldn't be calling me a young lady.
Sorry about the kitchen in the background. We're obviously a lot of us working from home these days, so this was the best lighting. Plus, I'm sharing an office now with my wife, who's a high school chemistry and physics teacher, and she normally would be at school, but she's not these days. So I don't know your patience on that.
So I don't see any other questions coming through. Once again, everybody, thank you. I will, if you want a number of people to send over, you want professional hours, I'll make sure Carrie Stewart gets it over. Almost our whole audience was pretty much on the consulting side. So we'll get those professional hours over there to you, Carrie Stewart. our marketing lady out of Grand Rapids area will be sending those out. Like I said, this video is on tape. If you want, I can always send you over the tape recording and we can send that over as feedback as well as I'm saying that. We're a resource, Steve, thank you for that. And our sales head, if you guys have any pump projects coming up that requires Penn Valley Pump, please give us a shout. We'd be happy to help you. We have a number of references throughout the state. And it's just been a great line for HESCO, and we appreciate everything Penn Valley. They're based out of Warrington, PA, outside of Philly. It's all US made. And that's all they do is Penn Valley Pump. They don't do anything else. So it keeps them more unique. So with that, Steve, do you have anything else to add?
No, we're good to go. Thank you again for your time. We really appreciate it. And everybody stay safe out there.
Thanks, Steve. Everybody stay safe.
Thanks for setting this up.
You bet. Take care.
Take care, guys. Bye-bye.